Okay, so hi everyone, so welcome back to the channel. So today in this video we will be discussing about this interesting Codeforces problem that goes by the name Xenia and bit operations, and it was asked in Div 2 round 197, and this problem is rated 1700. So we will see how we will solve this problem using segment tree, but first we will discuss the brute force method and then we will come down to the optimal approach. So the problem reads like this, that Xenia, the beginner programmer, so Xenia is the name of a person, has a sequence A consisting of 2 to the power n non-negative integers, and Xenia is currently studying bit operations. So to understand bit operations better and how they work, Xenia decided to calculate some value v for this given array. Namely, it takes several iterations to calculate this value of v. So at the first iteration, Xenia writes a new sequence. So this is a new sequence, and Xenia writes this new sequence from the original given array that consists of 2 to the power n integers, right? In other words, Xenia writes down the bitwise OR value of the adjacent elements of the sequence A. So in the first iteration, she wrote down the bitwise OR value of the adjacent elements, right? And in the second iteration, Xenia writes the bitwise exclusive OR. Exclusive OR means that is XOR operation. So she wrote down the exclusive OR of the adjacent elements of the sequence obtained after the first iteration, that is the bitwise OR operation. And in the third iteration, she again wrote down the bitwise OR of the adjacent elements, and so on. So in the first iteration, out of the given array, she writes the bitwise OR of the adjacent elements, and after the obtained sequence, she writes the exclusive OR, that is XOR of the given elements, adjacent elements only. And again in the third iteration, she again writes down the bitwise OR of the adjacent elements from the second iteration, and she continued to do so until she obtained a single element, that is v, and this is what she wants. Let us consider an example. Suppose that sequence A is 1 2 3 4. Then let's write down all the transformations of this array 1 2 3 4. So initially the sequence is 1 2 3 4, and according to her, what she want to do is she want to take the adjacent elements bitwise OR value. That is, first she will take the bitwise OR of this first and second element, right? So the bitwise OR of first and second element is equal to 3 here, as you can see. And then she again takes the bitwise OR operation of this third and fourth element. So the bitwise OR of third and fourth element is 7 here. So by doing this, she obtain two integers, right? That is this 3 and this 7. So initially the size of the array was 4 elements, but after doing the first iteration, the size of the new array will consist of just 2 elements, because we took the the bitwise OR of the adjacent elements, right? So this contributed to one new element and this contributed to one new element. So 3 and 7. So our new array is 3 and 7, and in this new array, she wants to take exclusive OR operation now for the adjacent elements, right? She took the exclusive OR of 3 and 7 and got 4, and now the size of the array is 1 only. So this is our v, and this is what we have to return. So for this example, the value of v is 4. So I hope you have understood everything till now, but there is something more in this question. You are given Xenia's initial sequence. Okay, so the initial sequence will be given, and we have to calculate v for the given sequence. But we saw that we can do this very easily, just as we did for this example, right? So there is a twist. What additional information has given to do is, we will be given additional m queries, and each query is a pair of integers p comma b, right? So for each query p comma b, we have to perform this assignment operation. That is, we have to set the pth index equal to b, and after each query, that is after updating these each index a of p equal to b, we have to again find this new value starting from the very start, and this number of queries can go up till 1e5. So the number of times the array value will change can go up to 1e5, and so we have to find the value of this v 1e5 times, right, in the worst case. So in the input, we will be given two integers n and m, but one thing to notice here is that the size of the array will not be n, but rather 2 to the power n, right? So 2 to the power 17 in the worst case, and the value of each element can go up till 2 to the power 30. So it means that it can be easily fit in an integer value, right? So for each of the next m lines containing queries, we have to set this pth value equal to b, and after setting the pth value, we have to find the fresh value of this v that the Xenia want. So print m integers. The ith integer denotes the value v for the sequence a after the ith query. And one important thing to notice is that the queries are not independent. Like, you cannot say that after setting the first index equal to 4, we performed the query and got some value of v, and then again the array returns to its original state. No, it is not like that. Once we have set the first index equal to 4, it will remain 4, and then we'll perform the next query as usual, right? So this is the given example, and the output given for this is 13333. I hope you have understood the problem correctly till now. So let us now go to the blackboard and see what approach can we apply in order to solve this problem. So this is the very first example given in the question. So in this example, the value of n is 2, the value of m is 4, that is 4 queries in total, and this is the given sequence, right? So this sequence consists of 2 to the power n, that is 2 to the power 2 number of elements, that is 4 elements, right? And this is our 4 queries here, that is 1, 4, 3, 4, 1, 2, and again 1, 2. And this is our required output. Let us now try to understand how the output for this example is this, right? So this is the given sequence, right? So according to the question, what we have to do first? We have to take the bitwise OR of the adjacent elements. So here, let me mark the indexes. This 0th and 1st are the adjacent elements, and also this 2nd and 3rd are also the adjacent elements, right? We cannot say here like this 0 and 1 are the adjacent elements, and then this 1 and 2 are the adjacent elements, and then this 2 and 3 are the adjacent elements. No, this is not adjacent elements requirement according to the question. We have to take it in pairs like this, right? Let us now start the bitwise operations. So what we have to do in the first step, we have to take the bitwise OR of the adjacent elements, right? So I will say that the bitwise OR of these two elements and the bitwise OR of these two elements. So by doing this, I will get two new elements here, right? So what are these two new elements? So by doing the bitwise OR of this 1 and 6, I will get what? So let us do here quickly. So I can write 1 like this, and I can write 6 like 0 1 1 0, right? So after doing the bitwise OR, I will get 0 1 1 1, and what this is equal to? So this is equal to 7, right? So by doing the bitwise OR of this first and second element here, I got 7, right? And in the same way, if we do the bitwise OR of this 3rd and 5, then what we will get? Let us do that here quickly too. So I can represent 3 as 0 0 1 1 and 5 as 0 1 0 1, right? So do the bitwise OR, so I will get 0 1 1 1. So again I am getting the same result as here. So this is 7. So currently we have 2 elements, but according to the question, we have to continue doing this until we have 1 element left in our current sequence, right? So currently it has 2 elements, so it means that we again have to perform the operation. So we will again do the same thing, that is, we again have to take the bitwise operation, but since we have took the bitwise OR operation in the previous step, right? In the previous step we took the bitwise OR operation, right? So it means that in this next operation we have to perform XOR operation, right? So this is what has been asked in the question to do. So by taking the bitwise XOR of this 7 and 7, we will get what? So if you know the XOR property, then let me do this here. So since 7 is represented like 0 1 1 1, right? So we have to take the bitwise XOR of these two. So we know in bitwise XOR, for the same element we get 0. So here I will get 0 0 0 0. So that is 0. So it means that by doing the bitwise XOR of the 7 7, I get 0. And now as you can see, we have finally 1 element left in our array. So this will be my value of v that has been asked in the question. right? But if you have read the question correctly, then first we have to perform a query every time and then we have to find v. So by doing this, you just understood how the value of the v will be calculated in every step, right? So let us now correctly solve this example by performing the queries in each and every step. So according to the first query, we have to set the first element equal to 4, and these indexes are given in one based only, right? As you can see that here this pi is starting from 1, so it is given in one based. So this means that I have to set the sequence arrays 1 minus 1, because I have used 0 based indexing here, equal to 4. So if I do this, then I will get a new array and it will look something like this. This will become 4 and this 3 will remain as it is, right? And now once I have performed the query, that is the first query, I have to find v, right? So let me write this here. Just now I performed my first query here, and once I have performed my first query here, I have to find its corresponding v value. So to find the v value for this query, I have to take the bitwise OR for these two elements and these two elements, right? What I will get after taking the bitwise OR, so let us find that here quickly. So bitwise OR of 4 and 6, I will get, let's find here. So 4 is represented like this and 6 is represented like this, right? So by performing the bitwise OR, 0 1 1 0, that is 6 only. So I will get 6 here, right? And by performing the bitwise OR for these two elements, I will get what? 3 is represented like this and 5 can be represented like this. So by performing the bitwise OR, I will get 0 1 1 1, that is 7, right? So it means that this will be 7. So in this way, the value of bitwise OR for the adjacent elements in the first step will be calculated. And after doing this, this is my new sequence, right? Which is obtained after performing the first query. But since the number of elements are still 2, that is greater than 1, it means that we again have to perform the query. So we will again perform the same query, but this time instead of taking bitwise OR, we have to take the exclusive OR operation, that is XOR, right? So what will be the XOR of this 6 and 7? So let us find here. So 6 can be represented like 0 1 1 0 as we saw previously, and 7 as 0 1 1 1, right? So by taking the exclusive OR, we will get what? 0 0 0 1, that is 1 ultimately. So this will become equal to 1. So in this way, for the first query, we found the true value of this v, and this is equal to 1. And in the output also, if you see, then the required value or the expected value is 1 only. So we found that, right? And in this way, our first query is done. Now I think it's time to perform the second query. And as I told you before, that the queries are not independent. So once we have modified this original sequence into this, we have to perform the assignment operation on this array only and not this array, right? So keep this in mind. So this is my current status of the array, and in this I have to perform the assignment operation. So what we have to assign? We have to assign this, that is, we have to assign value 4 on the third element, that is on the second index here. So this will remain 4, this will remain 6, this is now equal to 4, and this will remain 5, right? So this is my new array, and in this I have to perform my query 2, right? And in the second query, I have performed the assignment operation, and now I have to find its corresponding value of the v, right? Again, we will do the same thing as we did in the first query, that is, we will calculate the bitwise OR for these two adjacent elements and the bitwise OR for these two adjacent elements. So the bitwise OR of 4 and 6 will be, so 0 1 0 0 for 4 and 0 1 1 0 for 6. So it will be 0 1 1 0 only, and that is equal to 6 only. So it means that the bitwise OR will be 6 for these two elements. And for 4 and 5, let's calculate. So for 100, it's this only, and for 5, it is this. So the bitwise OR will look like this, which is 5 only. So the bitwise OR will be 5. And once we have done this, we again have to take the bitwise operation, but this time, since here we took the OR operation, so it means that now we have to take the XOR operation, right? So we'll take the XOR of this 6 and 5. So what will be the XOR of this 6 and 5? So since 6 is 0 1 1 0, and 5 is my 0 1 0 1, so by taking the XOR operation, I will get 0 0 1 1, that is 3. The final value of this v will become equal to 3 now. So let me erase this stuff quickly. So in this way we calculated the v value for the second query, which is equal to 3 here. And if you see in the expected output also, then it is equal to 3 only. So in this way we performed the second query and got the correct output. Now let us understand the output for the third query. So in this we have to change the sequence of first element, that is the 0th index here, equal to 2. That is, this element we have to set it equal to 2 here now. Currently the status of my array is this, so here I have to change this 4 equal to 2. So let us do that quickly. This 4 will become equal to 2 and these 3 elements will remain as it is, right? So for this new array, we have performed the assignment operation, that is second query, and got this array, and then for this we have to find this new value of v, right? So let's do the same thing again, that is take the bitwise OR of these two and the bitwise OR of these two. So what will be the bitwise OR of these 2 and 6? Let's find that here quickly. So 2 is represented like this and 6 is represented like this. So take the bitwise OR, so it will be 0 1 1 0, that is equal to 6 only, right? So it is equal to 6 here. And similarly for 4 and 5, 4 is represented like this and 5 is represented like this, so the bitwise OR will be this, that is 5. So 5 here. And once we have done this, we will continue doing so because the total number of elements are still greater than 1. We will now say that the bitwise XOR of this 6 and 5. So 6 is this, right? And my 5 is this. So the bitwise XOR will be 0 0 1 1. That is 3. So it will be equal to 3 here. So in this way we calculated the value of v for the second query and got 3. And if you see in the expected output also, then it is equal to, as you can see, it is equal to 3 here only, right? So this is equal to 3 only. So we got this 3 and also our third query is done. Let us now go to the last query, that is 1 comma 2. It means that we again have to assign the sequence of 0th index equal to 2 only, right? So I think we don't need to do that here because we have already assigned it to 2, right? And if you again assign it to 2, it will remain 2 only. And by performing the query operation for 2 6 4 5, we saw that the result was 3 only, right? So it means that even after performing the third query, the array will remain as it is, and because of that the value of v will also remain same, that is equal to this 3 here, right? So it will remain 3 only. So these elements will remain same because in the assignment operation the 0th index is not getting changed here, it is equal to 2 only, and if it is equal to 2, then this final value of v will also remain same, which is equal to 3 here. So that's why, as you can see in the expected output also, the final value is 3 only. So in this way we also found the correct output for the fourth query, right? So I hope you have understood this example correctly, like how the 4 outputs are coming for each and every query, right? So what we are doing basically is we are just taking the bitwise OR operation for the adjacent elements in pairs, and in the first iteration as we took the bitwise OR operation, and if the number of resulting elements are greater than 1, we have to take the exclusive OR operation, and in the next iteration if again the number of elements are greater than 1, we have to take the bitwise OR operation, and so on. That is, we have to do it in alternate fashion until we get one element, and that one element will represent the value of v for that particular query. And sorry, this was my first query, this is my second query, and this was actually my third query, and this was my fourth query, right? So how we will do the same thing using brute force method? Let's see. So in the brute force method, we will do the same thing exactly as instructed in the question to do so. So in the brute force, it will consist of mainly 3 steps, straightforward. That is, in the first step, we have to perform the assignment operation, that is a of p minus 1 equal to b, since p is given 1 based. And in the second operation, we have to perform the bitwise operations as discussed above in alternate fashion, right? So we have to perform this in alternate fashion. So we will continue doing this until we have only single element left, right? And whatever the only element remains at the end, that will be our value of v, and we have to return that. So without giving much time to this brute force method, let us go to the code editor and quickly code this up. So first we have to take the inputs of n and m, so like this, and we know that the size of the array will be what? So the size of the array will be nothing but I can write it like this, that is 2 to the power n. Let me declare this array here, for which I have to take the inputs. So its size is this, and initially let's say every element is equal to 0, So now let me take the input for this 2 to the power n elements. So I will start with 0, 1, left shift n, and then I plus plus. So let me name it as sequence, since in the question it is named as sequence only. So I will say sequence of I. So in this way the input for this array will be done, and after the input has been done I have to perform m queries, and in each query I will be given 2 integers, and since p is given 1 based, I will say p minus minus here first, and then I would say that the sequence of this p will turn out to be b. And once I have performed the assignment operation, what it told you to compute v. So I will write a function, and this function will return me the correct value of v, let's say f, and in the function I will be passing the sequence, right? And at last I just have to print this v, and instead of writing this v separately here, just we can write it directly here like this. So let me write down the function here quickly, and let us here also pass the size of this sequence here. So it will be this, right? Let's name it s here, or better n. And now what I will say is, since initially I have to take the bitwise OR operation for the adjacent element, so I will say that bool of OR is equal to true here first, right? And then I will begin my process, and I will say I will continue doing the operation until the size of my current array is greater than 1. So if it is greater than 1, then the loop will run again and again, and in each loop what I have to do, I have to compute a new sequence, right? So I will store this new sequence, let's say in a vector. Let's give it name as new underscore sequence, like this. Then what I have to do, I have to start my I less than n and I plus equal to 2, since we have to take it for the adjacent elements, right, and not contiguous elements. And one more thing is, don't name it as OR, instead name it as OR operation, like this. So once we have done this, what we have to do, we will check that if the OR operation, currently we have to do the OR operation or the XOR operation. So if it is true, then it means that we just have to perform the OR operation first. So I will calculate the OR value of these two adjacent elements, which will be equal to nothing but sequence of this I bitwise OR sequence of this I plus 1, and I will just store my this value in the new sequence like this OR value, right? And if this is not true, so it means that instead of doing this, what we have to do, we have to perform the exclusive OR operation, right? So this will become my XOR value, and just replace it with this sign and this. So in this way, for a given sequence, the operation will be done, and once the operation will be done, what I will say that before doing the next iteration, I have to change the status of the OR operation, right? So currently if it is OR, then I have to change it to XOR. So I will just say OR is equal to not of OR operation. So I just change from 1 to 0 or 0 to 1. I just flipped the value of OR operation, so that if it is XOR currently, it will turn to OR and vice versa. And also I will say that the value of n will change, and what will be the value of n now? It will be equal to the size of this new sequence, and my original sequence will now become equal to this new sequence only, like this. And after doing this, I will just return whatever the only element is remaining, that is sequence of 0. So in this way the function will be written. And there is a silly mistake I did here. Since I have passed the sequence here directly, and after doing this whole operation, the sequence is getting reduced to a single value, right? Because I have passed it through array of reference. When the next query comes, it sees this new sequence as a single element only, but we know that for the next query it won't be just a single element, it will be of the original size as the given in the question, right? So just do one thing here, make a copy of this array like this. So I will say temp, and this will be equal to my this sequence, and instead of passing the sequence, just pass temp here like this. So now after doing this, if I run the code, let's see. So as you can see, it is giving me the right answer, but we will not submit this because obviously this is a brute force method. And if you try to analyze, then what is the time complexity of this solution? So as you can see that this for loop is running for m times, and inside this for loop I am calling this function, right? And in this function I am running two loops, first this while loop, and inside this another for loop. So if I try to show you the time complexity here properly, then it would be something like this. So it would be something like, for each m query, right, for each m query I am calling the function, and in the function the first I am traversing the whole array half times, and then again I will traverse the same array but this much times, and so on until we have a single element left, right? So this is nothing but we will get this, and this is approximately equal to O of m into 2 to the power n only, right? So you can say like this is an exponential solution, this is an exponential solution, and obviously this will give TLE because the constraints are pretty high. And if any one of you is wondering what this thing is equal to, then it is equal to nothing but 2 to the power n plus 1 minus 1. So let us now discuss our segment tree approach for this question. So as you know that in a segment tree, it consists of mainly three functions. The first function is our build function, second function is our query function, and the third function is our update. So you must all be familiar with these three functions already, like the basic working and the code structure for the build, query and update, right? So this update function is used to update the status of an array either at a point or on the whole range, right? Similarly, this query function is used to answer a query for a particular range. And this build function, so this build function is used to construct the segment tree initially, right? That is, before we call our update and query functions, first we build this segment tree using the build function, right? That is the initialization of the segment tree using the given array. So this is the basic of the segment tree. So if you remember, then this was our given array, right? Now we want to construct or build a segment tree using this array. So you know what happens in a segment tree. Each of the individual elements present at each index, here 1 is present on the 0th index, 6 is present on the first index, 3 is present on the second index, and 5 is present on the third index, right? So initially what happens is these individual elements are present at the base level, right? So these individual elements will be present at the base level. So this 0, 0 represents a range and its corresponding value in this node. Similarly, this is also a range and this is also a range. So for the base level, the value of the node will be equal to the value of the element present on that index in the initial array, right? Now let's see what happens. So if you remember, then what the question has asked us to do? It has asked us to initially calculate the bitwise OR of the individual elements, right? And after we calculate the bitwise OR of the individual elements, if the total number of elements are still greater than 1, then we again have to do a bitwise XOR operation. And we have to continue doing this in alternate fashion until there is only single element remaining at the bottom level, right? So here also we will do the same thing in the segment tree. So since every initial element is present at the base level initially, so it means that we will start from the base level only, right? So now what we have to do? We have to take the bitwise OR of the first two adjacent elements, that is these, and these next two adjacent elements, that is these, right? So what will be the bitwise OR value of 1 and 6? So the bitwise OR of 1 and 6 will be equal to 7, right? And at the same time, let us also calculate the bitwise OR of 3 and 5. So it will be equal to, it will also be equal to 7 only, right? So we will say that the bitwise OR of 1 and 6 is 7, because this is what we have to do in the initial stage, right? That is on the first iteration of the original array. Similarly, we just calculated the bitwise OR of this 3 and 5, it is also equal to 7. So in this way, the bottom level is filled completely and also this level is filled here completely. And now we have to fill this level, that is this node. So now since we have done the first iteration on the original array, that is performing the bitwise OR operation on the adjacent elements, and got this two elements, right? And since the total number of nodes, or you can say the total number of elements, so these two represent these two nodes, right? So since they are still greater than 1, it means that we again have to continue doing the bitwise operation in alternate fashion. So since at this level, let me write down here. So at this level, we performed bitwise OR operation. So it means that at this level now, we have to perform bitwise XOR operation. So in this level, these two are the only adjacent elements, right? So on performing the bitwise XOR operation, what will be the value? So since these two are same, it means that it will be equal to 0, right? so it will be equal to 0. So in this way we filled the segment tree starting from the bottom level and going till the up level. And this is how the build function works actually. It goes recursively in the left part first and the right part, and then continuously combine the left and right results into the parent node. So here we combine the results of these two nodes into this node. Similarly, we combine the results of these two nodes into these two nodes, and then finally combine the result of these two nodes into these two nodes. So I hope you have understood now how the segment tree actually builds and how the segment tree in this question will be built. So the parent node in this case is a single element, and this is our required V, right? This is what we have to calculate each and every time after performing the query. Since this was our given array, we called the build function that is initialized the segment tree and in this way our segment tree is made up from bottom to top. First we calculated the bitwise OR of the adjacent elements, and in the next level we calculated the bitwise XOR of the adjacent elements, and thus we got the respective results each time, right? So now let us start performing the query. So what is the first query? So the first query is like this, that we have to assign. So the first query is like this, that we have to assign a value of 4 on the 0th index, right? That is 1 minus 1. If I try to do this here, that is in the 0th index, I have to assign a value of 4. So I have assigned now a value of 4 in this array. With that said, it means that I also have to update the status of the array in this segment tree. So I will call the function as, let us say the name of the segment tree is t. So I will say t.update 0th index equal to 4. So what this function will do, this will update my 0th index equal to 4. And if you see in this segment tree, then where is my 0th index located? So my 0th index is located at this range, right? That is the leftmost bottom node is my 0th index, right? So what does this update function will do? It will update this one value equal to 4 by recursively calling this update function. We will see later in the code how that will be implemented, and most of you must be knowing this already. So suppose now after reaching this 0th index through recursion of this update function, we have reached this, right? So now what it will do? It will change this one equal to 4, because this is what the query has asked us to do. And by doing this, what has happened? By doing this, if you see, bitwise OR of these two adjacent elements will remain same, that is will remain 7 or not. So it might or might not get changed, right? So let us see and try to do the new bitwise OR of this 4 and 6. So what will be the bitwise OR of 4 and 6? So it can be calculated like this. So 0 110 equal to 6 only. So it means that after I changed this 1 equal to 4, the bitwise OR of these two adjacent elements also changed. It means that I also have to update this 7 equal to 6 now. I think there should be no doubt in this. So what does our update function will do now? It will update this 7 equal to this 6 here, right? So this is equal to 6. The only change that was needed was here. Why? Because the bitwise OR from which this is made is changed, right? Earlier it was 1, so the result was something different, but since now it has been changed to 4 as per the query, so the bitwise OR will also change now. So that's why it is equal to 6 now, right? And again the update function will see that these two are my new elements, and it will try to evaluate the XOR value of this 6 and 7. Since earlier there was 7 here instead of 6, and the XOR of 7 was getting equal to 0, but since now this 7 has been replaced by this 6, so the XOR of 6 and 7 will not be 0 now. So this update function will recursively also calculate this new value. So what will be this new value? Let's see. So it will be like 0 1 1 0 and 0 1 1. So what is the XOR operation of these two values? So it is like 0 0 0 1, right, which is equal to 1 only. It means that our new value of V will be equal to 1 now, right? So we have to erase this 0 and write it 1 here. So in this way our new value of V will be calculated. And if you remember, then the answer to the first query was 1 only, and we are also getting 1 here after updating the segment tree right from the bottom to the top. This is what we have to print or return. So I hope you have understood this query very well, and let me now erase this so that we can move on to the next query. So right now this is the So right now this is the status of my segment tree, and this is the status of my array, right? So this array corresponds to this segment tree with the required values in each and every node. So what was the second query? The second query was this 3 and 4. That is, we have to update the sequence of second index equal to 4. So I will say that this 3 has now become equal to 4. And once I change this 3 equal to 4, it means that I have modified this array. It means that I also have to modify the segment tree on its corresponding index. That is the second index here. So if you see, then this second index is located in this segment tree at this position, right? So I will again call this update function, but instead of calling it for 0, 4, I will now call it for 2, 4. That is, we have to update on the second index and update it with a value of 4 now. So this update function will recursively call itself until it reaches this index, right? And after reaching this index, what it will do? It will update this 3 simply equal to 4. And as I just explained you in the previous query, that since I have changed this element now, it means that whatever internal nodes are present by going in the upward direction till the top, each one of them will be changed, right? So since I have changed this node now, it means that the bitwise OR of these two will also change. That is, the value of this will also change now. And if the value of this node changes, it means that the bitwise OR of these two will also change, due to which this will also change. So let us erase this and let us recalculate the actual values. So what is the bitwise OR of this 4 and 5? So the bitwise OR of 4 and 5 can be calculated as 0, 1, 0, 1. That is equal to 5 only. So it means that it will now become equal to 5, right? And now we have to calculate the bitwise OR of this 6 and 5. That is this. So it will be equal to what? It will be equal to 0, 0, 1, 1, which is equal to 3. So it means that the bitwise OR of these two elements is 3 now. So I will write 3 here. So this is our new value of V. And if you remember, then this is our required output for the second query as well, right? So in this way, we performed the second query and got the correct value of V. I hope you are getting the concept what I am doing every time, right? So let us now perform the third query. So according to the third query, let's see, it asks us to change the 0th index equal to 2, right? That is, the 0th index equal to 2. So this 4 will now become equal to 2. And since now I have changed 0th index equal to 2, that is this equal to 2. So I will call again this update function, and it will be something like 0th index equal to 2. So I have to update this 0th index equal to this 2 value, right? By calling this update function, it will recursively reach this node. And after it reaches this node, it will set this 4 equal to the new value that I just provided here, that is 2. So it will become equal to 2 now. And what we have to do next? Since I have changed this node, it means that every node that is present on this line internally, that is this 6 and 3, will be changed, right? Or will be modified, and others will remain as it is. So let us now erase these old values and recalculate the actual values now. So the bitwise OR of 2 and 6, that is 0, 0, 1, 0 and 0, 1, 1, 0. So what is the bitwise OR? It is 0, 1, 1, 0. That is 6 only. I will write 6 here. Similarly, now what I have to calculate? I have to calculate the bitwise OR of the 6 and 5. That is 6 and 5. So 0, 1, 1, 0 and 0, 1, 0, 1. So what will be the bitwise OR? It will be 0, 0, 1, 1, which is equal to 3 only. So again this is equal to 3. And this will be my new value of V here, right? And if you see in the output also, then it wants 3. So it means that we have got it correctly. So according to the last query, what we have to do, we have to set the 0th index equal to 2 only, and we just did the same thing in the previous query as well. Let me tell you what will happen. So now this last query wants us to change this 0th index equal to 2, but it is already equal to 2. So since it is already equal to 2, even if you don't call this update function, nothing will happen, right? But suppose if I call this update function, so what will happen then? It will recursively reach this last node, that is the node that we want to update, and will just simply update it equal to 2. That is, it will remain same as it is before, and then again this value will be recalculated and this value will be recalculated, which will be equal to 6 and 3 only, because this is not getting changed. And since this is not getting changed, each and every value in this direction will remain same, right? So again the final value of v will be nothing but this 3 only, right? And the expected output for the last query is also 3. So in this way we calculated the result of v for each and every query and got what? And got 1333, which is our answer also. So I hope you have understood the given example very well. First we saw the brute force solution and we saw that the time complexity of it was going exponential, which was not acceptable according to the constraints. And then we discussed the segment tree approach, in which I first explained you how to build the segment tree starting from the very bottom and going till the top. And once we learned that and built the segment tree and initialized it with the given original array, we started executing each and every query. And after each and every query, I told you after we updated the base node, whatever internal nodes are present on this path, that is from bottom to the top, only those much of internal nodes will be updated and other internal nodes will remain same as it is, right? So since I just need to travel through these much number of nodes in order to update 6 and then re-update the new values in this way, so it means that I am traveling this segment tree a total of log n times in going from up to down in order to reach 6, and then again a log n time in order to reach from the bottom to the top, because this log n is what? It is nothing but the height of the tree, right? And we make sure that our segment tree, whatever we build and initialize, it is always a balanced segment tree, and the height of a balanced segment tree is what? It is nothing but log n, and hence we just need to travel a total of 2 log n times, right? First in going from up to down in order to reach 6, and after we update 6, again going back to the top in order to update the new values, which is nothing but log n only. And thus we say that the update operation is a log n operation. So what is the new time complexity for this approach? The new time complexity is nothing but m for the number of queries, and what I am doing for each query, I am just calling the update function, and this update function is taking a total of log n times, right? So that's why I can say that my new time complexity is m log n, and this is far better than what we got previously, and this will get accepted into the platform. Also, some of you might say that what about the query operation? What will be the time complexity of that query operation? Why I am not taking that into account? Because whenever I will call that query operation, that is t.query, since my result is already stored at the parent level, that is this level, it means that I don't have to travel through any of the nodes in this direction or any direction, right? Because my result, that is v, is already stored at the top. And since this segment tree is nothing but an array, which we generally name as tree, right, or seg tree, so I will just return tree of 0. So what does this tree of 0 will represent? It will always represent the parent level value, that is this value. So I will just call this and it will give me the topmost value. So in that case, so that's why by calling this query function, it will not take me any time complexity. Now let me tell you one last thing. Some of you might be wondering that, okay, we got this, but how we will make sure that at each of the level we have to perform either OR operation or XOR operation? How we will determine this? Let me erase this stuff so that I can make you this thing understand much better. So what I am now saying is, how we will make sure that at this level we have to perform OR operation, or at some other level we have to perform XOR operation. How we will determine this? So in order to determine this, what I am saying is, let us maintain another array, and let's say the name of the array is level. So by name it is obvious that it will represent the level of that node, right? This level array will hold the level of each and every node present in the segment tree. So since there are a total of 4n nodes that we considered as the segment tree size, so this level array will also have a size of 4n only, right? So we know that this is our 0th node, and this is our first node, this is our second node, this is our third, this is our fourth, this is our fifth, and this is our sixth. So in order to calculate the value of the node for the left and right child, we do nothing but, if my parent node has a value, let's say node, its left child is calculated as 2 into node plus 1, and the value of the node for the right child is calculated as 2 into node plus 2, right? That's why, since the parent level has a value of 0 here, so 2 into 0 plus 1, which will be equal to 1 only, and it will be equal to 2. So that's why I named it here 0, 1, 2, 3, 4, 5, 6. You can calculate for each and every one, and the result will be same every time. So now what I'm saying is, let me write this level array here for a few of the elements. So actually this is of the size 4n, so it will go from 0 to 4n minus 1, right? So it will go till this point, but since here I have considered only 7 nodes, so I will write them here. So now what I will say is, so after I initialize the segment tree for the given original array in the question, that is calling the build function internally in the class, so each one of these nodes will be calculated, right? So at the same time, I will also fill this level array. So I will say that initially each one of these nodes in the base level has a value 1. The value of 3, 4, 5 and 6 nodes, that is these 4, will become equal to 1. And once these values will have been calculated, it's time to look upon these two now, right? So we will say now that okay, we filled the values in this array, no problem, and now we want to fill the level array for this two node values, that is this 1 and 2. So what I will say now is, since this has a level of 1, I will say now that the level of these two nodes will be the level of nothing but any one of its children node. Take any children, let's say the left one. So the level of the left child plus 1, level of the left child plus 1. So here it will become equal to 2, right? And after doing that, what will happen? I will fill the level value for the 0th node, that is this, and it will become equal to the level of this first node plus 1. So what is the level of the first node? It is equal to 2, right? So 2 plus 1, that is 3. So this will become equal to 3 now. So in this way our level array will be calculated for each and every node present in this segment tree. But how this level array will help us in determining whether to perform OR operation or XOR operation at that particular level? So it's quite easy, because what is the similarity between these three and these all ones? These all are odd, right? But these two are even. And this parity check will help us in determining whether to perform OR operation or XOR operation on a particular level by seeing the parity of that level. So suppose I am standing at this node, and we know that the level of this node now, that is 1, is 2, and this 2 is even, right? This is even. So if it is even, then what we will do? We will perform the bitwise OR operation. So let me write down here. So whenever if the level of a particular node is even, then what I have to do? I have to take the bitwise OR of left and right child, right? So since the level of this one was even here, I took the bitwise OR. Same for this, I took the bitwise OR because the level of 2 was 2, that was even, that is even. And now once the results are calculated for this level, I am present at this level. And now I will see the level of this 0th node in this level array. So what is the level of this 0th node? It is equal to 3. That is odd. So if it is odd, then what I will say is, if the level of an internal node is odd, then it means that I have to take what? I have to take the bitwise exclusive OR of the left and its right child. So here I will take the bitwise XOR of this left and right child, that is this, and hence this 3 will have been calculated. So in this way, this level array is helping us in determining whether to perform OR operation for a particular level or bitwise XOR for a particular level, right? So I hope you got the complete concept of this problem, how we use the segment tree and the level array in order to efficiently compute and update the base level node and compute the bitwise OR and XOR for each of the steps in log n time. This might have got little messy, but I tried my very best in order to explain you with the visuals. So I think now it would be very good for us if you go to the code editor and actually code this up and understand how this code is working and finally submit it on the platform, right? Let us now go to the code editor and code this up quickly and see if we are right or not. So this was our brute force approach, right? So let me erase all of this. Let me quickly paste my standard segment tree template here. So as you can see, this is my standard segment tree template supporting mainly three operations, that is build, query and update. So this segment tree template needs to be modified, right? Because currently it support range, sum and point update, and we have to modify few things in all these three functions, and also we have to declare another level array just as we discussed in the approach. But first let us code the approach in the void function and do the initial things. So what we have to do, we have to first take the inputs of this n and m, right? After taking the inputs of n and m, we have to take the input for 2 to the power n integers. Let's name it as sequence only, and the size of it will be 2 to the power n, initializing every value equal to 0. So just do this for taking the input. So just take the input like this. Once we take the input for the initial array, what we have to do next? I have to initialize the segment tree, right? So I will initialize this segment tree, and let's name this segment tree as a small t, and I have to pass this sequence, right? And just by calling this, what it will do, it will build the segment tree in the initial state. We also discussed this in the explanation in the starting point, right? And now I have to take the input for the m queries, so it will go from 0 till m minus 1. I have to take the input for two integers, that is p and b. So I will say p and b, just take the input, and since this p is given in 1 based indexing, so I will say p minus equal to 1, right? Thereby converting it to 0 based. And now what we have to do, update the segment tree, right? But before that, I will first update it in the original sequence. So I will say sequence of this p equal to this b, that is the new value, and then I will call my update function, that is t.update, update the this array at the pth index and set it equal to b. And once I do this, what is my last task? My last task is to just compute the query, right? That is, I will say t.query. I will just call this, I will not pass any parameter. Why I am not calling any parameter here? Because I know that my result will always be stored at the top level, right? So that's why I'm not calling any parameter, and then at last I will just do a return. So once we have written this code, let us now start modifying our segment tree template. So as I told you that in the query we don't have to pass anything, right? We just have to return what? We have to return tree of 0. So what does this tree of 0 represent? It represents the value whatever is stored at the parent node, that is this value. So just by calling the query function and returning this tree of 0, it will give me the desired value of v. So what is this? This is the value of v that Xenia wants, right? And once I do this, now I also have to modify this build, query and update function to some extent. So I told you in the explanation that whenever the build function will be initialized or be called in the internal class, then along with setting the value at the base level, I will also need to I will also need to assign the level array, right? So for that, I will declare a level array here. So I will say vector of int level, and it will also be of the size of 4n only, just like the tree, right? So I will say level dot resize 4 into n with each and every element initially equal to 0, right? So once I do this, I can start assigning this level array here. So I will say level of this node will be equal to initially 1. That is, what I am doing by this statement is, initially I am setting each and every element present at the leaf level, that is the base level, equal to 1, and this is an odd number, right? This is odd value. And then I told you, in order to decide for the internal node what will be its level, you can take the level of any of its child plus 1 value. So I can say here that the level of this node will be equal to level of any of its children. So let's say level of 2 into n plus 1. So this represents my left child, right? So its level plus 1. You can write 2 into n plus 2, that is the right level, right child also. That will not matter because the level of both the children will be same. So suppose for this particular level, I want to determine the value of this tree of node. So what does this tree of node will represent? It will represent either the bitwise OR operation or the bitwise XOR operation of the left and right child, right? So I will say now that if this level of the node is odd, so if the level of this node is odd, then what does it mean? It means that I have to take the exclusive OR operation, right? Otherwise I have to take the bitwise OR operation only. So let me paste this here. So if this is odd, then what will happen? We have to take the exclusive OR of the left and right child, that is this, right? Otherwise we have to take just the bitwise OR operation. So in this way I completed the build function, and let me copy this here because I have to do the same thing in the update function, because once we update the base level of the segment tree, the internal nodes values will also have to be recalculated, right? So that's why I will say here, instead of this statement, this. And now let's look upon this query function. So as I just explained you in the explanation very well, that our required final value of v will always be stored in tree of 0, right? That is this. So it means that we don't have to perform the query because the result is already stored at the top, right? So we can erase this simply. This is not needed here at all. And once I write this, I think I have written the code completely. That is initializing it with the build function, updating the levels like this, and determining whether we have to perform the XOR operation or OR operation. So this is doing the XOR operation and this is doing our OR operation, right? And once we do this, I just did the same thing in the update function here, right? Because the update function works in the same way as the build function most of the times. And I also erased the query function because this is not needed in this question because the result is already stored at the top, right? And I think I have written the code completely. So let's now run the code and see if this is working fine or not. I think I did a silly mistake here. I wrote it here level of node equal to level of 2 into n plus 1. So this will not be n, this will be node, right? So sorry for the silly mistake. So this will be node. So now if I run the code, let's see. So as you can see that the results are correct here for this test case. So now if I try to submit it on the platform, let's see if this is completely correct or not. Okay, so solution is accepted, and this is the code that we just wrote, right? And explained you each and everything in very detail about this problem. So thank you so much for watching this video till this point, and if you really liked the video, make sure to hit the like button, subscribe the channel if you have not subscribed already, and share with your friends who need to practice segment trees. I have also updated my social handle, so if you want to follow me or connect with me, you can check the about section of this channel. And if you have any suggestions regarding the videos, you can comment in the comment section. I will read those comments and will try to act on it. So yeah, thank you for watching this video.